Morning, everyone. Thank you so much for being here. Very excited. It's my first PyData, both attending and speaking. Very excited. Thank you to Rebecca, who actually prompted me to come speak here. She will be speaking also at 11:45. So definitely suggest you guys to check that out. It's been a great experience working on this, a great way to dive deep into a problem and expose it to the greater community. Without further ado, let's get to it. So I have 3 goals for today. First of all, explain some of the problems that arose when working with machine learning systems and specifically deploying them. Describe some of the solutions that exist and some of the limitations that those solutions have. And then I'll be speaking mostly about the tools and what you can do with them, but also what limitations arise more consistently, especially when you're working in a way that you're trying to build a workflow for doing machine learning so that you can deploy models with confidence. And lastly, I'll be open sourcing a library, which is exciting. I've been working on it for the past, let's say, month, and right now it's just closed source, and I've been working in mostly for personal interest and for some other side projects that use it, but it's closed source, and it's going to be fun, I guess, to open source it and present it to the larger community. So I'm pretty excited about that as well. So there we go. Some background on myself. I got my bachelor's in biomedical engineering and bioinformatics, mostly dealing with DNA data. And it was pretty interesting, at least working with like fairly large data sets. And biomedical engineering, usually you end up learning about many things, but nothing too in depth. So that was somewhat painful. So I decided to just pivot towards something that I was interested in, and that was software programming and machine intelligence and machine learning. I was lucky enough that I was working in a lab in which the PIs would let me just pick interesting topics and work within them. So I took like the fun machine learning classes and applied them to some very niche problems in genomic analysis, and that was interesting. But you start learning the pains of doing consistent or repeatable and consistent workflows within machine learning, and sometimes dealing with like just strangling like Jupyter Notebooks and so forth. And so that's something that since the beginning was kind of hard to deal with. So how do you manage the workflow of doing machine learning in general? And currently I'm working at ByCube, mostly within machine learning engineering. Officially data scientist, but mostly what I do is actually putting models into production and making sure that they get to the client's hands. In fact, some of the work is even front-end work, and the whole goal is just making sure that whatever models that are produced during the analysis phase, they actually get into the client's hands. So there's a lot of just ensuring that the whole process of doing analysis actually gets into production in a proper way, and that's most of my focus. And even not just in research, but also now here working in the industry with clients, you realize that the actual pain of putting out a consistent workflow that lets you deploy models consistently is a fairly big pain, or at least there are some limitations there that are somewhat hard to overcome, and you need some proper tooling for you to be able to manage the whole workflow. So takeaways from this whole time that I've been working both in somewhat in industry and research has been that you need those key features whenever you're developing workflows. Just one second. Sorry. So you need repeatable workflows. You need something that is fast, that enables you to do fast iteration, and the 80-20 rule that I like to call here, which is basically usually 80% of your results will come from. Is this working, by the way? Yeah, cool. From 20% of the work that you do, in the sense that usually a very simple model, such as like, I don't know, gradient boosting for whoever has done like a Kaggle challenge and so forth, will get you most of the results. And delivering those results quickly usually is something that matters a lot, especially when you have clients asking for results as soon as possible. And I know that this sounds almost like a pitch for Agile, but it's not, trust me. And I just want to make the point that you want to deliver those values as quickly as possible. So having good workflows, especially for data science and machine learning, helps a lot and helps the team deliver value as quickly as possible. So this is a quote, and the quote itself, I don't mean to diminish any machine learning expert with this quote, but the goal, this was actually taken from the Google machine learning suggestions for basically the best practice for machine learning, and basically states that some products for some products you don't need to focus on the very nitty-gritty details of the machine learning aspects, but more so you just need to focus on delivering a product that's actually workable. So focusing on the engineering first and on the actual product itself first should be one of the goals, because you want to deliver those values as quickly as possible. And one of the things that I've been focused on, at least doing my work at ByteCube and also beforehand, was actually providing those tools so that the data science team can benefit and just have a larger impact within the larger organization. So let's actually get to the core of the presentation. I've been very interested in TensorFlow and TensorFlow serving and the entire ecosystem that TensorFlow has created around it, mostly because it's a pretty interesting library, and for whoever has used it, it has a lot of hidden complexities, and sometimes it's hard to reason about it. But there's also usually I think most of the usages and examples that you see of TensorFlow are mostly on the training side, and how do you do specific models or how you implement them in, and not much of it has been focused on how you actually deploy it and you make it available for other people to be used. TensorFlow serving is Google's solution for how to deploy a model in an efficient, scalable manner. Basically, it comes with high-performance inference engine, and basically what it does is keeps the model loaded in memory so that you don't need to reload the entire graph, basically, when doing inference. And TensorFlow, who has used here TensorFlow? Any people? What about TensorFlow serving? One person, two person, okay. Yeah, so it's much less popular, but it's also a fairly recent addition to, I guess, the TensorFlow ecosystem. But it's an interesting tool. Well, TensorFlow, most people have used it, but basically what it does, or what it is just a scientific computing library that basically defines a graph of computation through which your data flow. So it's a data flow computational modeling tool, if anything. And something that is very computationally expensive, or it is expensive in general, is loading all your variables and loading all your graph into memory. And that's something that if you want to do inference, you need to do. If you have a model serialized as a particle buffer or whatever serialization format, it needs to be reloaded in memory, and after that, you can use it. But one of the cool things about TensorFlow serving is that that comes out of the box for you, and the model is kept loaded so that the inference is done quickly, and you don't need to wait for the reloading. It also has some other interesting features, such as a gRPC interface and a REST interface. I'm not going to go into the details of the differences of both, but gRPC usually allows for faster inference, so low latency, faster inference. And it also has some notions of model discovery, in that if you have directories where your models are stored within the TensorFlow, and TensorFlow can access them, then if a new version comes out, that is, if a new model gets loaded into one of the directories that TensorFlow serving has access to, then that model gets loaded automatically, so it's ready for inference. So it's interesting. It's not as flexible as you want, because the versioning that they use is just basically just integers. So you have a directory number 1, number 2, number 3, and then the latest is always getting loaded. So it's interesting, but not too flexible. Some details about how they achieve the high performance inference and the gRPC interface and so forth. I mean, basically, as I mentioned, it keeps the model loaded into the memory so that you don't need to reload it and reload all the variables, so that's great. And it also has a pretty extensive C++ API, which I would label it more as a limitation than a feature. It's pretty extensive in that you can control the very guts of it and how the models get loaded, and you can create your own version policies as to how the models get loaded, which is pretty cool. You can define also a few other things like what kind of inputs the model will receive and what kind of transformations you can do before the predictions actually happen. So you have a lot of control into how the TensorFlow serving will behave with the C++ API. But something that I mentioned before was that when we're trying to build tools, the goal is reducing the attrition between whatever data science is doing, whatever the developed or at least MVP product looks like. So requiring data scientists or whatever to use a C++ API seems to be a little bit of an overhead, at least right now. And it's interesting that they do have a Python API, but there's no documentation whatsoever. There's some snippets that you can find here and there, and that's somewhat odd. Maybe it's a fairly new tool, so I suppose the documentation is still catching up. But it's interesting to see that they have a Python library. Just recently, they just released one with a Python 3 support. It was only at 2.7, so also interesting, but undocumented, so there's some limitations there. And they actually only had a gRPC interface until August. And it was interesting because my talk was supposed to be just about how do you implement some REST interface in front of TensorFlow serving, and how you basically make the REST interface talk to gRPC interface. And that was going to be interesting. But then ever since they released the REST interface, it didn't make much sense for me to just talk about that, so I just decided to create something that went a little bit beyond. So it was interesting, I guess, but for sure, having a REST interface makes it easier for people to just use the tool and develop tools around the tool, and that's because, in general, I want to say that 95% of organizations, in the end, they use JSON over HTTP using the REST protocol, which is, the common standard way that, you do requests nowadays. Out of those limitations, my idea was, let's create something that has some nicer properties, or something that at least it's a little bit smoother to the user as far as like how you manage models, how you interface with them, how you deploy them, and how you query them even, and so forth. So that was something that I thought it would be interesting to work on and interesting to have a new look at, or at least a new take on. And what resulted from it was, a library that I'll be explaining to you later. But in general, all I wanted to do is just having something Pythonic, documented, with a nice, clean interface that lets you track models, but also serve them, and also just have easy access to. And in the end, also, someone will be consuming this model. It might be not yourself. It might be some other developer that needs to get predictions for front end or what have you. So the idea of having a clear interface and a clean way of looking at them is always something that we should strive for when developing software products. So before going to the library, I just wanted to take a quick look at what exists today and some of the tools that some of you may know and may have used. There's some great tools here. Clipper.ai is actually developed by the RISE lab at Berkeley. It's a great tool. They actually have many, many cool repositories within high-performance computing. Unfortunately, it hasn't been much active, at least since the last time I checked. So it's interesting because it supports many different machine learning libraries, and you can load models, and it's a high-performance C++ engine that does the predictions for you as well. So it's an interesting tool. Also works with containers, so you have also that ease of use, if anything. And then you have some other platform as a services type of tools like Algorithmia and Recognition from Amazon, and many other ones. And those are interesting, of course, if you want to have that full support from like an entire platform. Of course, you have the issues of vendor lock-in and being closed source and so forth. But those are great tools as well. And MLflow, which is by Databricks, it's also a great tool if you want to do experimentation of new models and you want to track the model performance over time. Not so much for proper serving, because actually, at least as far as TensorFlow goes, they do support it. But if you want to deploy something with MLflow, you'll have to, and you want to get a prediction from your deployed model, they basically do the whole, like, let's reload the model into memory, let's grab all the variables and all this serialized data and reload it and then do inference. So you're definitely going to pay a performance penalty there. But I definitely recommend people check out their project, because it lets you quite easily switch between, PyTorch, scikit-learn, XGBoost, and all the possible libraries, and basically try them out and track the performance over time and have some nice visualizations as to how they work. So it's a great tool, but maybe not something that fits the idea of having some nice performance properties. And then there's always custom solutions. You can find them on GitHub. There's many. Some of better or lower quality, but custom solutions exist. That's usually what ends up when you have a problem, a bottleneck, I guess, is you just create a custom solution, maybe open source it, maybe you don't, but there's always going to be some of them. So one I want to introduce you is a new, I wouldn't say a framework, but it's I guess, an opinionated way of deploying models using TensorFlow serving. And it's basically a pretty minimalistic model deployment tool that lets you get access to most of the TensorFlow serving functionality, but with a cleaner interface, well-documented, and technically easier to use as well. And, something that takes away most of the complexities and makes sure that you have some nice properties when you're doing your, machine learning workflow that, encompass being able to version your models, or being able to track the performance over time, for being able to visualize that performance over time. So you have some things that have been, at least in my experience, somewhat of a pain to work with, and have not been solved by some of the current solutions. So I wanted to put together something that would have a take on it that would hopefully add something to the discussion. The motivation, basically, as I mentioned before, I just wanted to have something that would let me automate my workflow and let me, get to some MVP, quicker, or get me to something that's working within, maybe a few minutes at most. That, goes back to the notion that within an organization that you need to develop a product for some client, you just need to get to something working as quickly as possible so that you can get that feedback and make sure that you're always improving moving forward. Something also that I thought was useful or would be very appropriate to have would be the ability to explore the models that you have access to, and basically have an idea as to how their performance has been from the past until what you have today. And you can track it and query it and store it in a way that allows you to basically have access to that model metadata moving forward. And lastly, flexibility. I think it's important. We don't want to, or at least ideally, the tool shouldn't lock in the user into something that requires you to go through hoops to change a single configuration, and it shouldn't make the user change the entire workflow when developing a model, for example, and shouldn't have to just change 20 different configuration files when trying to deploy something. So it should be something straightforward that doesn't change the data scientist's workflow, but allows you to have some nice properties as far as managing the stuff that you develop and the models that you produce. So, of course, wouldn't be a data science talk without some mention to version control or some meme about it. But basically, one of the features that I wanted to make sure that it was there and it worked in a nice way would be the ability to have something that automates the versioning of your models and make sure that whenever you want to look at the history of the models that you have trained, you can take a look at the versions of them and their performance, and also basically how they compare against each other, and so that you can basically select the version that performs the best, for instance, or you can cycle through models that have similar performance but different characteristics. So something something that, so that's something that, at least in my experience, has been like hard to deal with, especially when, I don't know, whenever you're working with scikit-learn, for example, and you need to pickle a model, you pickle it or you store it, serialize it in whatever format, and it's hard to keep track of which one did what or which model, performed how, because, I mean, all you have access to is just the name of the file in the end, or maybe some directory in which you stored it. So that was something that I felt it was fairly limiting, or at least was somewhat just hard to work around, and whenever you're doing that multiple times, it becomes a little bit painful for you to keep track of that. And that's the same for, I mean, whatever library you're working with. Sometimes doing the proper versioning takes some extra effort. Something else that I wanted to make sure is that, I mean, the name of the talk has Flask in the name, but I haven't mentioned it too much. But one of the goals was also having a friendly interface for other, basically, if you were to deploy a model, you need it to be easy to use by others. So something that I wanted to make sure is that whenever you serve a model, you have also a nice interface that's self-documenting and allows people to just query it using the most common types of tools like curl or whatever requests library that you're using, so that you have access to that in a nice way. So basically the library itself has built in a way of creating a server that lets you access the model, and it uses Flask and Flask RESTful, which is a basically an API building library, and that comes with Swagger documentation out of the box, which is also great. Always makes it easier to develop things and share things with other people. Another things that I wanted to have since the beginning was a nice expressive CLI, just because I think being able to have access to most of the functionality through a few commands would be easy, would be great, or at least like it would make sense for the common user that wants to have access to most of the functionality with very few keystrokes. And also static typing, because Python 3.6 and 3.7 are great, and the optional typing features from developed with MyPy and so forth are pretty awesome, and usually help with like having code that documents itself, and having people, whenever they look at your code, they will get a better glimpse of what the code is doing if you have the types there, and it makes the developer experience much easier. So I also definitely recommend that for people. Cool. So this whole talk, I guess, has been mostly, or at least the idea has been like developing this way of like having a way of doing machine learning that it's more understandable, or at least more clear, not only to the person who's developing the models, but also the person who's interfacing with them. So, I see two personas here that the library should target, and one of them is the data scientist or the machine learning practitioner that is actually developing them, but also other software engineers, other developers that will be using the results of the model into either some front end or some other place that requires the outputs of a machine learning model. So from the developer's perspective, we want to have something that's easy to integrate, easy to deploy. So something that I focus on also was getting Docker to work out of the box, or at least having Docker as a starting point from anything you'd be deploying. And that's usually a very nice way to make sure that workflows are reproducible, and whatever you're running will run in other places. So the Docker plus the RESTful access were things that usually make the developer experience at least a little bit more enjoyable. And visibility also, being able to know what are the inputs for the model, and being able to basically query an endpoint and know what the data should be for that specific model is also useful, because sometimes you don't want to deal with like issues with your NumPy arrays, sizes, or shapes, or whatever. Usually those arise pretty commonly. And then from the other perspective, here I have a sample code of how you would define a model using the library, which is interesting. I mean, I think it's pretty standard, but basically you just inherit from a class that has some some methods that will allow you to store the model and automatically push it into the TensorFlow serving library so that it's already serving. But basically, the goal here is just having a workflow that doesn't put any major constraint on the data scientist and lets you develop, the workflow the way you used to do it before, but it gives you extra functionality that you can use if you wish to. So, the build model method is just, a classic Keras sequential model that, defines a few layers and returns the compiled model. All there else that there is in this class is just the definition of a version, a name, and a model type, and a call to store method, which basically does all the things that I mentioned, that is storing the model in the proper format, putting into TensorFlow and serving it automatically. I'm going to give a quick demo later, or actually at the end of the talk, so you can see how you would use this and how you would go from this to something that's serving a machine learning model in like a minute and a half. So you'll see more or less. But again, I guess the point, or the larger idea here is that if we want to develop some workflow for doing machine learning, we want to make sure that we don't put any barriers to data scientists and we don't mess up the workflow, or at least don't put any constraints, and make sure that it stays as consistent as it was before. And whether it be on a Jupyter Notebook or on some like Python file, this at least doesn't at least my experience, it shouldn't add any constraint or any difficulties as far as like how you do the machine learning, but it gives you some added benefits as far as how you serialize, version your models, and so forth. So actually, the demo is actually right now. So I'll just show a quick recording of my screen while it's going to be maybe a little bit too small. Let's see if we can zoom in. So first of all, this is Askinema, which is a great tool, also written in Python for recording terminals. I'll recommend if you ever need to give a demo or showcase something, it's a great tool. But in any case, so I'm just gonna say that this is a clean environment with just the library installed and nothing else, an empty directory, and I'm just gonna type some commands and get to, in the end, to a model that's being served within TensorFlow serving with those nice properties, and well, that's pretty much it. So just quick note, something that I like doing is just having, whenever developing a project someone will use, have a way to just, not have to start from zero, but start from like some point in which you already can get to something that works with the least amount of time. So that first command basically generates the scaffolding that you need and all the Docker files and configuration files that you need to deploy your first model with not much attrition. So that should, that init just creates the directory, creates the scaffolding, and you have access to all those the Docker files and the Docker Compose files. The Docker file contains the definition of the TensorFlow serving, so it's actually taken pretty much straight from the TensorFlow serving library with some modifications to make it work with the project, but that's pretty much it. And then some started files like this one and this one are just like the sample files that I showed you pretty much on the previous slide. So you have access to those just so that you can start playing with it. So this is the file that I showed before. Docker Compose file, nothing crazy here. Then we're gonna run the Docker Compose command to start off the container. Of course, it will take some more time to build it if it's if you haven't downloaded. It's a fairly large image actually, but once you do it once, that you're good to go. Of course, that was like 4 epochs, I think, or epochs of like very small neural networks, so that was very quick, but you can imagine that might take as long as needed. But so once you run the model and you call that store method, then it's already loaded into TensorFlow serving, and it's already ready to make predictions. And you can do some other querying of the models and see what exists. That's like one of the CLI commands lets you, take a look at that. You can query the active model. Okay. Right, and then to actually start off the API server that lets you actually do requests to the model. You need to start it. There's a specific command, but that will basically stand up the Flask server with the API and so forth. And starting in the background so we can clear up the command. Well, we can now test it. Just send a simple curl request, and you get your predictions back pretty fast. And it basically that queries Flask, queries TensorFlow serving, gets your predictions back. So there you go. That's pretty much it. And I guess a meter and a half, you can get to a nice model running in production. This is actually on the, oops. Let me go back. Oh, where is it? Oh, here. Yeah, the docs have some more information about it. I tried making them pretty extensive, and here's the project. Still haven't done much, or at least haven't, it's still actually private. So what I wanted to do today, as I mentioned in the beginning, open source a library. So that's exactly what I'm going to do. Again, I've been working on this for the past maybe month and a half, 2 months, and it's been pretty exciting, but I wanted to make sure that other people can have a starting point. Again, this is not a bulletproof solution by any standard, but it's a way that maybe will give people an idea of how you can create a workflow or something that creates a workflow that lets you, have access to some set of tools that I found to be interesting, at least in my time doing machine learning and deploying models. So the model versioning, model serializing them automatically, and so forth. So those are the things that hopefully someone will get some maybe some useful snippets or some code that might be interesting. So go ahead and make it public. Oh, haven't done this before, so don't really know. Oh, damn it. Nice. Cool, it's public. And that's pretty much it, actually. I do have a slide with that talks about the moving forward, but I guess you can find that in the documentations as well, as far as what's missing in the library. So I'll just open it up for questions now.
Thank you, great talk. Now that Racket is open source, what are some of the things you would like potential contributors to consider contributing? What is missing from your perspective that we should think about?
Sure. Well, first of all, it's something that I've used sparingly here and there, and mostly developed in a way that it could be used by others, but at the same time, I haven't used it extensively enough to know what bottlenecks are and when it fails. So testing is one thing, and it has a decent coverage, but many edge cases, I only catch them when I'm actually typing the commands and seeing that it goes wrong. So testing is one thing. Second would be, let's see, maybe some explanation or some workflow that would take you that to some actual deployed version on some of the major cloud providers. For example, having a Kubernetes example deployment, or maybe AWS, ECS, or what have you. So those things that are, things that I didn't take too much time just because, time constraints, but those things that would be interesting for people actually using it and actually deploying models would be great, and testing always.
I have two questions. One on, are the metrics stored in the SQLite database?
Yeah, actually, so thanks for mentioning that. Usually you can specify on there's a racket.yaml file that gets generated once you initialize the library, and you can specify the connection string to your database. I use SQLite and if you specify a Postgres connection, then you can use that, for example. But the idea is just having, I use, SQL Alchemy, and SQL Alchemy basically has the ORM to store the data. But yes, it's all stored in a SQLite database.
And when you send the model to the Docker, the Tensor Serving API with the CLI, how is the data transferred?
Great question. It's actually through Docker volumes. So you specify the volume of your file, basically a directory inside the project that's actually gets created automatically, and then you specify that volume to be inside some model that gets some directory that gets mapped inside the Docker container, and so you get that nice sharing. So you don't need to copy data at all; it's just there. So, but actually, that's a good point as far as like, what if you want to deploy it? Sometimes the Docker volume, and I'm kind of hazy on that, but sometimes if you want to deploy something and you have the data in the volume, you need to freeze it, or at least you need to actually copy it there if you want to, for example, push the Docker file to some repository. So that's a good point, and I'll keep that in mind, yeah.
Hi. No, this is a super awesome project. I'm definitely going to use it. A question that I have, I'm not familiar with TF serving, but I assume that it's really good at getting like the inference to run as fast as possible. But once you have like your Flask server and you're trying to intake in a lot of request as well as data that is just huge, like an image, like what would be good kind of tools or like how can you beef up your Flask server once it's now kind of served, like with like TensorFlow serving?
That's actually a great question, and something that I've thought about myself. The Flask, the idea is just having like an API that it's well known to people, and you have this nice Swagger documentation and all that. But something that I've been thinking about is just using the TensorFlow serving, semantics that are built in, like using the gRPC interface, which allows for, bidirectional streaming and, just much faster access. And they use protocol buffers as a serialization instead of JSON, which is, much more efficient. So something that I thought about was like, what about, and I haven't implemented this yet, something that I thought about was, what if we, have the Flask to basically document the actual gRPC interface so that people, when using, they can choose between using the gRPC interface or using the Flask if they just want to use the simple JSON, so you can have both.
So then to ask also something else, I guess if I was kind of more interested in this, should I look more into the gRPC in like to TensorFlow serving to figure out how to best handle all this incoming data, or are there just better other kind of libraries for these kind of incoming requests?
That's if your bottleneck is inference performance, and that's actually like the reason why Google released the TPUs was actually just bottlenecks in inference, then you should definitely look into the gRPC and the actual barest metal type of like solutions, which are usually the gRPC ones, and that will boil down to the C++ inference engine that they have. So Flask, I guess, yeah, you can maybe something that I still need to do actually was on the that needs to be done is the batching of requests, so that batching usually performs better than one-offs. So having a way of doing that. But you can give Flask maybe a better performant WSGI server that would maybe help, but you still have a bottleneck. With the gRPC, usually you have better characteristics. It implements a better HTTP protocol. So I would look into that if that's your bottleneck, and then maybe distribution as far as like distributing load across many servers and so forth. And you even using TPUs at that point. But yes. Flask will be your bottleneck in case you're trying to like push it too much. Yeah.
How about security? Is there anything else we should be thinking about special with security here?
It's a great question. That's that's something that I haven't really taken a look at too much, but or at least I haven't like given it enough thoughts. But I mean, if you're going to really be exposing the endpoints, you should definitely have at least some sort of like some security practice in place, of course, and whether it be just TLS encryption or maybe getting access to tokens. That's something that I guess I've been working on something related to it, but not within the context of machine learning. So security, I guess, it's usually better left to the experts, but. I agree that's something that's definitely lacking. And contributors, if someone wants to take a look at how to implement something that will help making the endpoint secure in some way, I'll be more than happy to take a look at that. And as you mentioned, I guess it's a big issue, and luckily enough, Flask has a lot of options as far as like plugins for security, but I haven't taken a look too much into those. But
thank you. Maybe time for one more question. Anyone else? All right, thank you. Let's give a round of applause to Carlo.